Hello and good day to all my dear students. In last video we have completed our chapter number 5 simultaneous linear equations. Now today we are going to start our new chapter number 10 Pythagoras Theorem. Students, I know that in last standards you have used your Pythagoras Theorem concept, but here we again learn it thoroughly and we have to apply it in our questions to solve. So first of all you have to see the figure given in here slide, that here triangle ABC is a right angle triangle at B, means angle ABC is equal to 90 degree, and here side AB is given 3 centimeters. So you can see on side AB there is a square drawn, that is ABFG square, in which 3 3s are 9 squares are drawn, you can see, and side BC is equal to 4 centimeter. So on side BC you can see 4 squares are drawn, and ultimately there also a square BCDE is drawn. It contains 16 squares. BCDE square contains small 16 squares. Then side AC is we can find out, because this is Pythagoras theorem. Two sides are given in a right angle triangle, so we can find the third side. So here AC, if we want to find out, then what do? We will add AB sides all the squares and BC side all the squares, means on AB side there are 9 total squares and on side BC there are 16 total squares. So 16 plus 9 become 25 squares, which we have drawn on side AC. You can see on AC side there are 5 squares, and ultimately on that square ACKH there are 25 squares. Now we take, if the AC squares square root, then we get 25 square root 5. So our side AC is 5 centimeter in this triangle. So students, this is our geometrical representation of Pythagoras theorem. You can see that Pythagoras theorem, we have learned that hypotenuse square is equal to the sum of squares of other two sides. Here AC is hypotenuse, which is the longest side of a triangle, and it is always opposite to 90 degree angle. Here angle ABC is 90 degree given and AC is opposite to it. So we call our AC is a hypotenuse, which is the longest side, and AB and BC are other two sides of a triangle. Okay, so students, you have to remember that always the square on the hypotenuse of a right angle triangle is equal to the sum on the squares on the other two sides. So here this is our Pythagoras theorem. You have to remember long way, or you can say AC square is equal to AB square plus BC square, because there are three sides in a triangle and AC is the longest side, hypotenuse. So AC square is equal to AB square plus BC square. Now students, see the another figure. In this figure also there is a right angle triangle whose two sides are small a and small b, and the hypotenuse side is given as small c. Now you can see that the side A, on it there is a square and its value is a square, and on side B there is a square and its value is b square, and on side C is hypotenuse and its square is c square. Students, if in a triangle, if three sides are denoted as small a, b and c, then we can represent our Pythagoras theorem as c square is equal to a square plus b square. You can see now in the questions, when you are given this type of two sides in a triangle, you can find the third side. Always you have to remember this relation, that hypotenuse square. So c square is equal to a square plus b square. So if you are given b and c values, you can find a value, and if you are given a and c value, you can find your b values. So here students, some of the points you have to remember in this chapter is that the right angle's opposite side is always hypotenuse, and hypotenuse is the largest side, or you can say the longest side of a right angle triangle. Then in the right angle triangle, the square on the hypotenuse, you can see here the square on the hypotenuse is always equal to the sum of the squares on the remaining two sides. And you can find ultimately, if one side or two sides are given, you can find the third side of a right angle triangle, which I have written as a formula here. You can say these formulas you have to remember now. If angle B is a right angle, then AC square is equal to AB square plus BC square. Or you can say, if opposite to side AC, it is denoted as C, and opposite to side AB, it is denoted as A, and BC as B. So we can write C square is equal to A square plus B square. And just now, as I explained you, that if two sides are given, you can find the third side. So here, if C and B are known, so you can find your A side as A square is equal to C square minus B square. And if A and C values are known to you, then you can find your B value by using B square is equal to C square minus A square formula. So now students, we will apply all these formulas to solve our questions in exercise 10A. Now here in exercise 10A, question number 1, in a right angle triangle ABC, C is the length of the hypotenuse and A and B are other two sides. So students, in last standards you have already studied about Pythagorean triplets. So here nothing but we are using our concept of Pythagorean triplet and finding our third side here. So I have taken number 4 of this, in which small a is given 10 and C is given 21. So I want to find value of B. For that, as I explained you earlier, that if two sides are known, you can find always a third side using Pythagoras theorem. So I am using Pythagoras theorem as B square is equal to C square minus A square. So I am substituting my values, like C is 21 square minus A is 10 square. So now solving it, we will get our B value. Now by taking square of 21, we get 441 minus square of 10 is 100. So by subtraction, B square is equal to 341. Therefore, our B value is under root 341, as we know that 341 is not a perfect square number. So we cannot find it square root in a whole number. So we will write it as it is in under root sign. So B is equal to under root 341. Taking now number 5 of same question number 1. In question number 5, A is 9 and B is 9. So we need to find C value. For that, we are again applying our Pythagoras theorem. C square is equal to A square plus B square. Now we substitute our value of A and B here. So A is 9 square plus B also 9 square. And taking squares of 9, they are 81 plus 81. So now taking addition and calculation, we will get our C value. You can see 81 plus 81 is 162. So to take now square root on both the sides, I have split my 162 value. It is 81 2s. So by taking square root, C is equal to 81 square root 9 and 2 square root 2. So my C value is 9 root 2. So this way students, you can find rest all the questions by using Pythagoras theorem. If two sides are known, third side you can find out, and these all are the Pythagorean triplets, we can say. When two sides are given and third side you can find out, always using Pythagoras theorem. Now let us see next question, question number 2. In question number 2, a rectangular field is 30 meter by 40 meter. What distance is saved by walking diagonally across the field? So students, we will understand the question first by figure. You can see the figure here. I have drawn a rectangle ABCD in which side AB is 40 meter and side BC is 30 meter. Now as you know that in rectangle opposite sides are equal. So BC is 30, so AD also 30 meters. Now it is written in the question that what distance is saved by walking diagonally across the field, means our diagonal in this figure is BD. You can see BD is the diagonal and they asked to walk in a diagonal way to save the distance. So you can either walk by A, B, then B, C and then CD. But to save the distance, you can also walk diagonally as BD. So for that, as you know, and rectangle, all the angles are 90 degree. So here angle A is also 90 degrees. So AB is 40 meters and AD also 30 meters, because opposite sides of rectangles are equal. Now we want to find our BD value, and BD is our diagonal and it is also opposite to angle A, and angle A is 90 degree. So BD is our hypotenuse in triangle ABD. So now students, in triangle ADB, I use Pythagoras theorem as BD is a hypotenuse. So BD square is equal to AB square plus AD square. And I substitute the value of AB as 40 square plus AD 30 square. Now 40 square is 1600 and 30 square is 900. This is very easy to write as 4 square 16 and 3 square 9. And if 1 0 square, then 2 zeros we have to keep. Now add 1600 and 900, you will get 2500, and by taking square root on both the sides, we get our BD value 50 meter, which is they asked to find out. So what distance is saved by walking diagonally, that you have to find out here, and that is 20 meter. Why it is 20 meter? Because if you walk in that way, that first AB, BC and then CD, then it takes longer distance. It takes 70 meters. But here we have just walked across the diagonal and it is 50 meters. So 70 minus 50, it become 20 meters. So our actual answer which is saved is 20 meters, students. So you have to write one more step here, that is 70 minus 50, 20 meters. Then question number 3. In question number 3, a man travels 7 km due north, then goes 3 km due east and then 3 km due south. How far is he from his starting point? So first of all, see the figure, we will understand by the figure. I have taken my starting point as A. So first of all, due north 7 km. So AB is north way 7 km. Then goes 3 km due east, means BC is east 3 km, and then 3 km due south. So CD is 3 km due south. CD is again downside, means south side. So we want to find that how far is he, means at the point D, how D is how far from the starting point A, means we want to find our distance AD here. So you can see the figure. I have shown first of all AB is 7 kilometers, but I have joined here ED. You can see in the figure ED. So I get BCDE a square, and in a square all the four sides are equal. So I have written all the four sides 3 kilometers. But AB is 7 kilometers. So out of that BE is 3, we will subtract. So I get my AE value 4 kilometers, as 7 minus 3, 4 kilometers. So now we write here AB is equal to 7 kilometers, BC is equal to 3 kilometers, CD is equal to 3 kilometers, which is everything given in the question, and AD value we need to find out. And BCDE, as I told you, that is form a square here. So all the sides of BCDE are same and they are of 3 kilometers. Now as we subtracted that half part, that ED is 3 kilometers, so AE is 7 minus 3, 4 kilometers, means we get all our distances. Now we use Pythagoras theorem in that triangle, that smaller triangle you can see, and that we get our AD value. So now in triangle AED, AD square is equal to AE square plus ED square. Why? Because as you know, in a square all the angles are 90 degrees. So here also our which angle is 90? That angle E is 90 here. So AD is a hypotenuse. Now substitute the value, AE 4 and ED 3. So 4 square 16 and 3 square 9. And by taking calculation we get our AD value. So here 16 plus 9 is 25, and then taking square root on both the sides, AD is equal to 5 kilometers. So you can say, students, that he is 5 kilometers far from his starting point. This is our final answer. Now let us take next question. Question number 4. The diagonals of a rhombus are 12 centimeter and 9 centimeter long. Calculate the length of one side of the rhombus. So students, as you remember our rhombus properties. So here we are given diagonals D1 12 centimeters and D2 9 centimeters. Do you remember the rhombus properties we have studied last year in quadrilateral chapter? It was like that in a rhombus the diagonals bisect each other at 90 degree, means they are perpendicular to each other. So I have written here D1 is perpendicular to D2 and they are bisecting each other and forming 90 degree where they intersect each other. This is our property. You have to remember this for a long time. Whenever it can be asked, you should understand this is the property of diagonal for rhombus. See the figure here, ABCD is a rhombus and BD and AC are the diagonals drawn which they are intersecting at O. Here I have drawn 90 degree also where they are intersecting, and it is also there in the property of this diagonal property that they bisect each other. So one diagonal is of 12 centimeters, so I have written 6 bisecting, and another diagonal is of 9 centimeters, so bisecting it I have written 4.5 and 4.5. So now they asked to get the value of side of the rhombus. So students, I am using triangle AOB. So OA and OB are known to you. So we can find AB value using Pythagoras theorem, as angle AOB is forming 90 degree angle. It is also written here that OA is 4.5 centimeter and OB is 6 centimeter, which are the two sides of right angle triangle AOB. So using Pythagoras theorem we will find our side AB. So let us see, in triangle AOB, AB square is equal to OA square plus OB square using Pythagoras theorem. Substitute the value OA 4.5 square, plus OB 6 square. Then taking square of 4.5, it is 20.25 plus 6 square is 36. So by adding we get the value 56.25. Now taking square root on both the sides, we get AB value is equal to 7.5 centimeters, which is our value of the side of a rhombus. And one more thing students, that in a rhombus all the sides are equal. So you can say the rhombus is having 7.5 centimeter as it's one of the sides. So students, we have completed up to question number 4 in this exercise today, and we will continue in the next video further. Thank you for today.